Alright, sets of real numbers. So there are a whole bunch of notations you'll need to know about. I'll be going through them in this video. If you want to just pause the video, write them all down, or skip ahead, feel free to. I'm just going to go through them here. So what a set is it shows you a collection of objects. Usually we use it as numbers, but it can be anything. Elements are what's in the set. So for example, set A, you have 1, 2, 3, 4, 5. 2 would be an element of set A. Now, the way we show elements is on the second line. The statement 2 is an element of A means 2 is in A. And then obviously, whenever we're not of something, we'd put a cross through. If you have a subset, that means it's part of the original set. So B is a subset of A because B has 1, 3, and 5, which belongs in A. If it's not a subset, then you just put a cross on as per usual. Important ones that you will always see. Union. The way union is shown, U for union. Okay. Union means you want to show anything that's in both, so either A or B. So if you did A union B in this case, you would have 1 that's common in both, 2 because that's an A, 3 that's common in both, 4 which is just an A, but then 5 as well. You might then ask what's the difference? Well, we're trying to write down all the different elements that are in both, and you shouldn't count them twice because you're just showing what's in there. If you did A intersection B, then we want to show what's the same in both, which is in just 1, 3, and 5. Don't get them confused. Intersection is just showing what's the same. Exclusion, so it shows anything that's not in one set compared to the other. So if you have a look, the exclusion A excluding B would be anything that's not in B, you just show what it is. Right, so we'll keep going down. Complement means not in that set, and then disjoint sets means there's nothing in common. You use a null set or an empty set to show that, which is down here, and then there's a few more. All right, so there are different types of numbers. Let's start with n. N is a natural number, which is anything that's countable. Now, you might notice 0 is not written in there. 0 is normally not counted as a natural number because you can't naturally count 0. We just say there are no numbers there. That's the reason why. Integers. Integers are any whole numbers, negatives or positives. Q represents rational numbers. Rational numbers are anything that can be written as a fraction. You can read the list for an example. And then Q dash would be anything that's not rational. And the last one is R. R means real. That covers pretty much all the numbers except for irrational, except for imaginary numbers, which in methods we're not going to go through. All right. A. Classify the following numbers as an element of a subset of real numbers. So 1, it can be written as a fraction, so it's a rational number. So we'll just show it with the symbol, which is Q. 2, that is an irrational number, so Q dash. 3, that's a normal number. In fact, it's 0, so I think they use that. 4, square root of 9 is a 3, so that's also a rational number. You can use Z or N, up to you. B. Which of the following are correct statements? Is 5 an element of Z? So is 5 an integer, in other words? Yes, so it must be correct. Not yes, correct. 2. Are integers a subset of natural numbers? Incorrect, because it's the other way around. If you saw the circles earlier, N is in Z, not the other way. 3. All the real negative numbers and all the real positive numbers make the real numbers. Now, this is going to annoy you a little, but that's incorrect. The reason for that is it's missing 0. 0 is neither positive or negative. So whenever you put a symbol on the top, if it's a plus or minus, that shows whether or not it's positive or negative. R negative means you have 0 here. We're not including 0. So this is R negative. If it's R positive, we have the same thing, but going the other way. You can see that it doesn't include 0 at any point. Now, I've showed you some interval notations on the last little section. You should have seen some of these intervals before. If you haven't, they're all here, and we use different symbols to show them. At this point, if you would like to, feel free to pause the video, have a read through it. I'm not going to spend too long on it. All right, illustrate the following on a number line and express in alternative notation. So what's the number line? So we have -2, 2. 2 has a square bracket, so it's a closed circle. -2 has an open bracket, has a circular bracket, so it's an open circle. And then in alternative notation, you just write down that x is an element between -2, whoops, to 2. All right, so what this says is x is such that x is an element between those numbers, which is what's shown on the number line. All right, the other one, we want x is greater than or equal to 1. So 1, closed circle to the right. So then this one, the alternate notation would be a set notation. We want it starting from -1 to infinity. Now with infinity, you always use a circular bracket because you can never include infinity. It's not a real number. I'm going to cross out this last one because you don't really need to show it with other notations. If you do, you can have a look at the textbook. It's a little bit odd. Use interval notation to describe the set of numbers shown on the following number lines. So we want it between 3 and 5 for the first one. So 3, 5, isn't simple. Circular brackets because they're closed, they're open circles. And then the last little section are enclosed circles. So we want less than 3 to -infinity up to 3. And we're also including 5 and up.